Hello everyone, this is Module 5, Part 2 of Chapter 5, Data Modeling with the Entity Relationship Model. Where we left off in Part 1, we were discussing how the ER model and where it fits into our design process. So we talked about how our ER modeling is really going to be the basis of our logical database design. And we introduced the 4 components of the ER model, which was entities, attributes, identifiers, and relationships. And where we left off was relationships, because that's where we can really add some value to our data and how it's related to one another. So relationships our entities can be associated with each other based off of a few different things in regards to how we define our relationships. We also talked about in Part 1, we talked about if a entity has a relationship with itself, that's considered urinary. If an entity has a relationship with one other entity, that's considered binary. And then if an entity has a relationship with 2 or more entities, that would be considered ternary, or a degree of 3. So a degree of 1 for urinary, a degree of 2 for binary, and a degree of 3 for ternary. We also talked about that typically in our ER models we can give our relationship some type of name that describes its function. Okay, that function is not always, giving it a name in our ER diagram is not always necessary. However, sometimes it's important to show the name of the relationship. And you can actually name that relationship or give that function of either of the entities or both, in terms of going from left to right or from right to left in regards to how they relate to each other. Typically, relationship names are a necessity when there are 2 different relationships between the same entities or same 2 entities. So again, our ER models is really helping us to define what we're doing and really trying to figure it out. So giving it a name on your ER models is always going to be helpful. Okay, so again, the degree is the number of entity classes that's involved in relationship, urinary, binary, or ternary. Okay. And then lastly, where we left off is the difference between an entity and a table, because you heard me referencing that how we look at our entities is exactly how we look at our tables. Is the main difference is that you can show relationships between entities by just giving just by showing a line between the entities, as opposed to in tables you actually have to show, in order to show a relationship with another table, you actually have to have a primary key, and then you have to place a foreign key in another table in order to express that relationship. So when we're just talking about lines and symbols, this makes it easier for us to work with in the early design process. Again, we're going to take our ER models. Our ER models is what's going to drive our logical table designs in our database. So if we are able to really mold and play with different ways of how we want to create our relationships in our ER model, then our table designs are going to be much better and more efficient. So moving on, the term cardinality is expressed within our relationships. This word means count. We have a maximum cardinality, which is the maximum number of entity instances that can participate in a relationship, and the minimum cardinality is the minimum number of entity instances that must participate in a relationship. Okay, so what we need to understand is that this does not lead to, the degree is the number that's participating, but this is max cardinality is really talking about the actual entity instances, not the entities themselves. So the degree of the relationship is the number of entities, where cardinality is going to actually start talking about the actual instances of that entity. So how we would look at tables and rows, which would the rows would be kind of equivalent to instances in our entities. This is helping us define the maximum number of rows or the minimum number of rows that must, so either can or must participate in that relationship between those two tables or those two potential tables or the entities themselves. Okay, so we start off with maximum cardinality. Maximum cardinality can be broken down into three different types. And again, these are your can participate relationships. So we're talking about one-to-one, one-to-many, and many-to-many. Okay. When we have in our example here, in our first example, you see we have a one-to-one relationship of an entity instance that has a relationship between employee and badge. So what this is essentially saying is that at most one employee is going to have one badge instance. Okay, so no employee has more than one badge, and no badge is assigned to more than one employee. Okay, in our second example, we're talking about maximum cardinality again, which is represented in the diamond in the middle. And this is an example of the original or ER model or Chen's model, because remember how it used rectangles and diamonds and so on and so forth. But in our second example is an example of a one-to-many relationship. So here a single instance of employee can be associated with many instances of computer, but a computer instance is associated with at most one instance of employee. So according to this particular example, an employee can be associated with several computers, but a computer is assigned to just one employee. Okay, so the positions of the 1 and n are very significant. So when you're looking at a diagram and you see the 1 and the n, the 1 is close to the line connecting the employee, which refers to the one side, the employee side, and the n is close to the line connecting to the computer, which means that the n refers to the computer side of the relationship. So if it were reversed, then it would take on a different meaning. Okay, so just make sure that you understand that in regards to meaning. And in our last example, we have a many-to-many relationship where an employee can have many skills, and a skills can be associated with a number of different, a specific skill can be associated with a number of different employees. Okay, so again, this is how we can recognize or examples of our maximum cardinality using the original Chen's model. Okay, so there's a term that the book starts talking about in regards to parent and child type relationships. Parent and child relationships typically refer to one-to-many relationships. So when discussing one-to-many relationship, the terms parent and child are sometimes used in the book. The parent is always going to be the entity on the one side of the relationship, and the child is the entity on the many side of the relationship. Okay, so in our example here with employee and computer, our employee would represent the parent and the computer would represent the child. Okay, so make sure that we understand that too, because this is going to help us identify down the road. This will help us, especially when we go from ER model to logical table designs. This is going to help us with our foreign key placement. Okay. The type of relationships we've been talking about so far just now is what we call has-a relationships. So each entity instance has a relationship with another instance. This term is used because each entity instance has a relationship to a second entity instance. So like in the example of employee and badge, an employee has a badge and a badge has an employee. But if the maximum cardinality is greater than 1, then each entity has a set of other entities. All right. So an employee, like in regards to skills, an employee has a set of skills, for example, and a skill has a set of employees who have that skill. our other example here at the end in our many-to-many relationship. Okay. So minimum cardinality is the other one. Again, we talked about maximum and minimum, but minimum cardinality is the number of entity instances that must participate in a relationship. Generally, minimums are stated as either 0 or 1. So if 0, then participation in a relationship is considered optional. If 1, that means 1, then at least one entity instance must participate in that relationship. Okay, which is considered mandatory. So if you see a oval, an oval on your ER diagram, that represents 0, and then a slash mark represents, or a vertical hash mark represents 1 in a minimum card or required. So really we're talking about 0 or 1, but in essence we're talking about required and optional type relationships in our minimum cardinality. So maximum can be one of three things, one of three things, one to one, one to many, or many to many. And minimum cardinality can be one of two things, which is either optional or mandatory. Okay. Let's see here. That's what we just talked about in regards to the oval and the hash mark. So here's an example of the three types of minimum cardinality and how you would see them again in the original ER model using shapes and diamonds. Our maximum cardinality is indicated in the diamonds, and then our minimum cardinality is indicated with the shapes closest to the entity. So in our first example, for minimum cardinality, we see that an employee has remember our maximum was 1 to 1, and then notice our minimum cardinality means it is mandatory. So if we have a badge, that's saying it has to be assigned to an employee. And if we have an employee, that employee has to have a badge, at least one. Okay, at minimum it's going to have one, and maximum is going to have one. So this is a really clearly defined 1-to-1 type relationship. In our second example, which is optional to optional, what we're saying here is that we can have an employee without a computer. However, in terms of our maximum cardinality, the employee can be assigned many computers. And then in vice versa, we can have a computer that's not assigned to an employee because the relationship is optional. However, at most or maximum, a computer will be assigned to one employee. Okay? And in our last relationship, example in the many-to-many relationship, what we're saying is that if we have an employee, he has to have at least one skill. Where in vice versa, if we can, that skill does not have to be associated with any employee. However, it can be associated with many employees, as well as going back the other way, employees can have many skills. Okay, so make sure that you understand the difference between maximum and minimum cardinality. So the whole idea of crow's feet notation is to simplify our data models and with our modeling products that we use. So a number of different data modeling products are available, and they have their own different ways of doing things. So for this class, we're using Visual Studio 2013, which handles the crow's foot notation as we are discussing in the book. Okay, crow's foot notation helps us eliminate some of those shapes that were given to us in Chin's early model, or the original ER model. So in the original ER model here, if you see in example A, we have our maximum cardinality that's indicated in the diamond, and in our minimum cardinality that's represented with crow's feet notation closest to the entities. But this is where our variations change quite a bit. So if you notice in example B, the maximum cardinality is the indicator that's closest to the entity, and then our minimum cardinality is indicated on the inside of that relationship. So whatever's closest to the entity is maximum. Whatever indication in the inside would be considered your minimum cardinality. So in this particular example, our relationship or cardinality between the department employee is 1 to many, and then our minimum cardinality between department and employee would be optional to mandatory. Or in general speaking terms, what this is saying is a department can have many employees, but if we have a department, we have to have at least one employee. And then going back the other way is saying, and if you have an employee, it has to be assigned to at least, if you have an employee, it does not have to be assigned to a department. However, if it is assigned to a department, it's only going to be assigned to one. Okay, that's the maximum number it can be associated with department. Okay. And then same thing here with our many-to-many crow's feet notation here with employee and skill, as we already discussed, with our maximum cardinality closest to our entity, and then our minimum cardinality on the inside. Okay. The next concept that we need to understand or talk about is the concept of strong entities and weak entities. So a strong entity is an entity that represents something that it can exist on its own. So it doesn't require another entity to exist. However, the concept of a weak entity is also defined as an entity whose existence depends on the presence of another entity. Okay? So an ER modeling includes a special type. ER modeling includes a special type of weak entity, which is called ID-dependent entities. Okay? An ID-dependent entity is an entity whose identifier includes the identifier of another entity. So in our examples here, you notice building an apartment, okay, and then painting and print, okay. If you look here in our examples here, this is just logical extensions or subunits of the parent. So this would be a parent-child type relationship where the identifier of building is included in the identifier of the apartment, because naturally an apartment cannot exist if the building is not there, as well as a print cannot exist if the painting is not there, or an exam, we can't give an exam if there's no patient. Okay, so a weak entity is an entity whose existence depends on another entity. All ID dependent entities are considered weak. Okay, and the identifier of the parent does not need to appear in the identifier of a weak child entity also. So sometimes we can have them, it can be a ID dependent type situation, or it can be non-ID dependent. So in our examples here, we have two examples of auto, model, and vehicle. And we notice here where we have manufacturer and model in vehicle as an ID dependent representation, and then we just have VIN number in a non-ID dependent relationship. Okay, so you know which one is more appropriate would depend on what you're trying to do with that particular data. Okay, and I think I skipped one point I want to make sure that we understand. If we do have an ID dependent entity to the parent, it's always going to be one. It's always going to be one. Okay, so in our example here, our minimum cardinality from the ID dependent entity to the parent, so from apartment to building, or from print to painting, or from exam to patient, is always going to be one, meaning mandatory. It's going to be a mandatory, at least one, it's going to be associated with at least one entity instance of that parent entity. Okay, so how we identify relationships, solid line connecting, an identifying relationship is a solid line connecting an ID dependent entity to its parent. A dashed line is considered non-ID dependent, but they can also be weak, but it's considered non-identifying. Okay, so non-identifying is the dotted line, identifying is the solid line. Okay, here's a quick chart and summary of ID dependent and weak entities. There is a little bit of ambiguity in the definition of a weak entity, because it can be interpreted differently by different database designers or different books. The bottom line is any entity whose presence in a database depends on another entity, then an entity that participates in a relationship having a minimum cardinality of 1 to a second entity is a weak entity. Okay, so that kind of helps us work through that ambiguity. As long as it hits on those marks, then we should be fine. Another type of relationship we need to talk about is subtype entities. This was introduced in the extended ER model, but a subtype entity is a special case of another entity called its supertype. So in our examples here, just like a student can be an undergraduate student or a graduate student, okay? Those would be considered subtypes of the supertype student, okay? Subtypes can be broken down into two ways of looking at it. If a supertype has what's called a discriminator, then those subtypes becomes what's called a exclusive subtype or exclusive subtype relationship. Okay, so a discriminator in this example here in our supertype would be the is grad student reference or attribute in the supertype. If you do have a discriminator and it's exclusive, that means that it has to be one or the other subtypes. All right, so the student has to be either an undergraduate student or a graduate student if it has a discriminator. Okay, so if subtypes are exclusive, at least one supertype relates to at least at most one subtype. If a subtype are inclusive, then one supertype can relate to either one, all, or none of the subtypes. That's an inclusive situation. So here's an example of how you would see an exclusive illustration of an exclusive entity relationship with its subtypes, and then a inclusive relationship, and everything is based off of the discriminator. If there is a discriminator present in the supertype, then the supertype will has to be either one. It will be one or the other subtypes. In an inclusive subtype relationship, notice there is no discriminator, so it can be one, both, or none in this particular case of this. So if a supertype has to be in one of the subtypes, then the supertypes are what's considered total subtypes. If a supertype does not have to be in any of the subtypes, then the subtypes are partial subtypes. Okay, so make sure that you understand that too, the difference between total subtypes and partial subtypes. This indicates a total requirement you will put a hash mark on a relationship line just below the supertype entity. That indicates the supertype is a mandatory in the relationship, and then the other one will be indicated with the discriminator. These both subtypes, when we have subtypes, those are considered ISA relationships. So ISA relationships means that a subtype is a supertype. Subtypes, and we understand the concept of inheritance. So if we go back to our example here, notice the identifiers of the supertype are always the identical identifiers in our subtypes. So make sure that you understand that the identifier of our supertypes always become the identifiers of our subtypes. But essentially what subtypes help us deal with is it helps us deal with the and helps us avoid, remember we talked about the common design problem of null values or inappropriate nulls. This can help us really put valuable data in when needed. The next couple slides here of part 2 I would definitely use for your reference, because this kind of gives us a summary of the different type of maximum and minimum combination, maximum cardinality, minimum cardinality in identifying and non-identifying type relationships, as well as our subtype relationships that you can go back and reference, especially for testing purposes, so it can help you kind of break down what you're seeing, and then to help to figure out what how one entity relates to another based off of the solid line, dotted line, and crow's feet notation associated with each entity. Okay, this is the end of part 2.